Morning, Sid. I have the MC14490 chip, the debouncer installed right here. It's more simple wiring. I mean, I only need one wire from the switch and then one wire to the microcontroller. These other wires are for the monitors that I'm using, the oscilloscope and stuff like that. But it is working, both with the button on the breadboard. That button has a little more bounce. It's also working with the button on the LJ cockpits unit. So if I go over here, you can see the signal. Let me let it clear here. So watch, I'll go fast. Certainly able to keep up, and if I go that same speed, there's a little jitteriness. There's the way this works is there is a delay in the chip, and if you're going very fast, it's not quite as smooth as the Schmitt trigger was. There was hysteresis, but the capacitor had to recharge, but the hysteresis inherent to the Schmitt trigger actually allowed it, as soon as the voltage made the certain level, it allowed it to switch, and then it didn't make a difference. So the capacitor charge that occurred after that point was irrelevant, as long as it, as long as the capacitor charged to the point where the logic level would change, you're fine. We could also keep in mind that the RC values that we selected, or that I selected for that circuit, were based on Derek's example. I didn't compute them. We can change the value of the resistor and the value of the capacitor accordingly if we want it to be shorter. To be honest, even though this works, I actually like the Schmitt trigger circuit that we used yesterday better. That was like bulletproof. Everything I could throw, as fast as I could push the button, everything I could throw at it, it worked perfectly. This is all right. I'm going to play around with it. There's, in the data sheet, this says you could put a capacitor across a couple of terminals. I don't know if I have it quite figured out yet, but for example, I will set this for a signal. You can see the actual signal looks okay. Okay, so now there is the signal. If I make it a little bigger and pan down a little bit, you see the yellow signal, by the way, is the input, and the blue is the output going to the microcontroller. This is a non-inverting device, where the Schmitt trigger was an inverting device. So when the input went high, the Schmitt trigger went low, and vice versa. But it's all right. This works okay. I think it's a little expensive. I think the Schmitt trigger and the resistor and capacitor might be cheaper if we could select the values accordingly. I don't know which. Well, probably this would be easier to put on a board. I think that we should probably look into the debounced I2C GPIO extenders that Gail mentioned. That would probably be the next step, although those are going to be very difficult to do on a breadboard. Well, essentially impossible, the way I understand it. So, but it's certainly, if you just use this the way you would typically use it, that fast, even that fast, you'd probably be fine, and you don't see it missing at all. I'll show you both here. Hopefully the phone focuses. You don't really see it missing at all. I have to go to 200 milliseconds, and we'll give it a second here. So now, let it clear. So it works. It might be fine, and maybe I can adjust it in the data using the data sheet. I can add a capacitor to filter a little bit, so we'll see. That's it.